Hi, my name is Konrad Krawczyk, and today I'm going to talk about antibody numbering schemes. I'm going to talk about what they are and what software is out there to perform your antibody numbering. So regardless of whether you are a seasoned antibody engineer or just starting your work with antibody analyses, I hope that this is going to give you a good overview of essentially like what is out there. So firstly, what are antibody numbering schemes? My understanding was always that this is just a bioinformatics way of sidestepping the MSA for antibodies. Because when we're working with proteins and we want to see whether there is a conserved position or whether there is a variable region, we take a lot of sequences of proteins that are similar to one another, we make an MSA, and then we see if there is a variability or there's not. Yeah, so it's conserved. For antibody, because they are so similar to one another, you can essentially pre-compute such MSAs in a way. So whenever you come to me with a new sequence of an antibody, I can tell you right away whether a certain position is a certain column in the set pre-computed MSA, whether it's a part of a framework, whether it's a CDR. So in this matter, you can actually facilitate your antibody comparability. You can right away contextualize to different functional regions without actually having to gather a full database of sequences and make an MSA out of them. So what numbering schemes are out there? So the first one was Kabat. It was created by Kabat and Wu many, many years ago when they firstly collected a bunch of antibody sequences. They made an MSA. And from this MSA, the known antibody structure emerged of conserved frameworks and variable CDRs. As more antibody sequences and structures emerged, new schemes came to light, such as Chothia, which is a more structural focused scheme, or the IMGT, which deals with insertions and deletions in the CDRs in a better way, so that you can actually compare the CDRs better to one another. I wouldn't say that there is one scheme that is better than the other, and I'm sure that we're not covering all of them because there are plenty. But I'll give you a functional example of why one should be careful when applying the different schemes. So here we have the sequence of trastuzumab numbered using several different schemes. One thing you would notice is that the CDR definitions are quite different to one another. Again, this is not to say that one definition is definitely better than the others, but when you are analyzing the sequences, you should really make sure that you just stick to one. So if your organization uses one of the older schemes like Kabat and Chothia for some legacy reasons, you should stick to that to make sure that there is comparability between the sequences. If you want more towards comparing the CDRs to one another, I would stick to IMGT because they are dealing with insertions in a better way. So what pieces of software do we have for antibody numbering? I would broadly categorize them in two buckets. One, those that are performing amino acid sequence analyses, and those that are performing nucleotide sequence analyses. Those that are performing amino acid sequence analyses, you just come with amino acid sequence of your variable region, and they are applying one of the numbering schemes. Here you have softwares like AntPack or Anarchy that are performing in a more statistical way, or like our piece of software Riot that does it in a more deterministic, old school sequence alignment kind of way. In the nucleotide world, you generally resort to IgBlast. So this is a piece of software that, given raw nucleotide sequences, it would delineate your CDRs and it would translate them into amino acid sequences. So one note here is that I mentioned our piece of software Riot, what we wanted to do is essentially to bring those two buckets into one so that you have one piece of software that can perform amino acid and nucleotide sequence analyses. So where can you essentially perform such sequence analyses? Most of the pieces of software that I mentioned are free to use. So I think that Anarchy is one of the most used free academic pieces of software to perform amino acid sequence analyses. IgBlast is also free, and it is very widely used for nucleotide sequence annotation. However, you can also perform such annotations using our platform. If you want to annotate a single sequence and get a contextualization to germline genes, the CDRs, and apply different numbering schemes, you go to the sequence engineering module and just pop your sequence in there, and the results are going to come out with a lot of other annotations. If you want structural context to your antibody numbering, you would go to the structural numbering module. Over there, you get your antibody numbering, but annotated right away onto a structure. If you have a whole bunch of sequences, be it amino acids or nucleotide sequences, then you would go to the batch sequence annotation, and over there we would perform the numbering in your favorite scheme. You get all of your annotations and you can download them right away or analyze on our platform. Thank you very much for listening. I hope it was informative.